Okay, copy this problem. Now question says, so this compound, you have a keto form, this is because you have a keto group. This is your enol form because you have all and in, so this is a enol form. Problem says this compound mainly exists in enol form, so this is the enol form is the major product, or you can say at equilibrium it will mainly exist in majorly it will exist in enol form. So you have to give me the reason why this mainly exists in enol form. And let me give you a hint. You can write some resonating structure for this. And what are the driving force for this? So you look for some driving force here. And you look some driving force here. You will get the answer. In this case, what are the driving force? In this case, we have very less driving force. And that's why equilibrium will go this side, because driving force this side is more and this side is less. You have to look the driving force. I will give you 1 minute time. Let me give you a hint. So showing this lone pair is enough. Okay, I think all of you have done this one. So you see, how can I convert the keto form to enol form? So let us say this is your keto form and there are two hydrogen, that is alpha hydrogen. So this is the keto group and I have two alpha hydrogen. So these hydrogens are acidic. If I press this group here, so if I replace this hydrogen and this goes here, so if I attach this hydrogen here, I will have enol form. Now you see, in this case form, this oxygen is basically sp2 hybridized. This is also sp2 hybridized. This is sp2, this is sp2. So all are sp2 hybridized. This means this lone pair, one lone pair is in sp2 and one lone pair is in pz orbital. Now this compound also contains 2, 4, 6 pi electrons. So all rules are fulfilled. So all carbon are sp2. Basically oxygen, in this case you have one oxygen, that is also sp2, and you also have 6 pi electron. So this all fulfills the criteria for aromaticity. So this compound becomes aromatic. Are you getting? So this compound is aromatic, and that's why this system is stable. First listen and then you write. Now see, what is the driving force for this side? If you see this molecule only have one kind of resonating structure, you can write resonating structure. This goes here, this goes here, this goes here. So this is a conjugated resonating structure. You can say there is a conjugation. So this is extended resonance. So you see, in this case, what is the benefit is, I have extended resonance. So this is the driving force for this side. That is the extended resonance. But if you see this side, so if you put the extended resonance, you will have this resonating structure. So these are the two resonating structure that basically stabilizes the keto form. But in this side, enol form, the compound becomes aromatic, and the driving force, the stabilization due to aromaticity is much larger than the stabilization due to this resonance effect. So aromaticity wins over the resonance effect. Aromaticity wins over the delocalization, even this extended delocalization, and that's why keto form is major, enol form is major form in this case. What is the reason? That is the aromaticity. You just copy this one. I think you have copied, some of you. So let us copy fast. Okay, let us discuss the next problem.